everyone, welcome back. My name is Josephine De Silva and I'll be teaching you physics O level, which has course number 5054. So we're continuing with the same topic, physical quantities, units and measurements. So we'll be discussing measurements of length today. So when you talk about length, it is the distance between 2 points. The SI unit for length is meters and it is a scalar quantity. If you'll remember, scalar quantities are those that have magnitude only without showing any direction. So length is a scalar quantity. Now length can be measured with using the unit meters, but for our convenience, for smaller lengths, we use centimeters and millimeters, like the length of a pencil, maybe the length of your rubber and so on. Whereas even for further shorter distances, we can use micrometer as well. That is, for example, measuring the length of your bacteria and so on. For larger distances, we use kilometers, which a lot of you already know, because in measuring distances from one point to another, like I had discussed earlier, Clifton to Gulshan, Johor. Fine. Now there are different instruments used to measure length. That is your micrometer screw gauge, you have your vernier caliper, your measuring tapes, as well as your meter ruler. All these instruments are most commonly used to measure lengths. You'll be using them in labs as well, like your measuring tapes, and your meter ruler is used at home as well in your classroom. Let us look at them closely. The first one we use is meter ruler and measuring tape. The term meter ruler comes from 1 meter. So a meter ruler has a length up to 1 meter, or you can say 100 centimeters. Whereas your measuring tape measures lengths longer than 1 meter. That is, it goes to several meters. Sometimes if you look at the measuring tape used by the tailors, the soft one has a length around 60 inches. Whereas the other ones which are used, the metallic ones which are used by carpenters and electricians, go to a longer distance of 4 to 5 meters. Anyways, the smallest unit the instrument can measure, if you look at the diagram below showing you your meter ruler, when you look closely, look at the smallest length. The smallest length, or when you look over here, is 1 millimeter. So 1 millimeter is known as the precision of the instrument. That is, you cannot measure anything smaller than 1 millimeter over here. Okay? And this is also known as the accuracy. Accuracy tells us the maximum error that can occur in an instrument. That is given by plus minus 0.1 centimeters. For example, if you have a length that is coming to 3.9 centimeters, so the maximum error you can have, or there is chances that your answer could be 4.0 centimeters, or it could be 3.9 centimeters. So that's how they say accuracy in terms of the maximum error that can occur in your instrument. For example, if you look at the diagram here, it's showing you a feather on a ruler. If we need to measure the length of the feather, you notice it's not starting from the 0 mark, but it's starting somewhere in the center. This is a better way of measuring length, because if your ruler is too thick, or if wear and tear may occur, that is, the markings at the starting, like the 0 point and the first 1 or 2, usually get erased with constant use. So if you keep it in the center, you reduce those errors, which are known as random errors. So what you do is you take the two readings at the different points. First one, if you take over here, which is around 29 millimeters, and you take the one over here, which is 10 millimeters. You subtract both the readings, and which gives you 19 millimeters, which is your distance, or you can say the length of the feather. Next we have is your calipers. A caliper is an instrument used to measure thicknesses as well as internal or external diameters, which cannot be done by using a normal meter ruler, right, or a normal measuring tape. So when you look at the diagram, you have your outside calipers and you have your inside calipers. What happens is that these instruments are used, you take your caliper, place it on, suppose the beaker you want to measure, the external diameter. You place it, you take it out, then you place it on your ruler and measure the length. But again, this is not a very accurate way of doing. The calipers can move, as a result your readings may be wrong. So in order to make it more accurate, you have your vernier caliper. And you look at the diagram, the vernier caliper looks somewhat like this. You have your two sets of jaws, your inner dimensional jaws and your external ones. The inner dimension ones are used to measure internal diameters, and the external one is used to measure external diameters. Then you have your stem to measure the depth over here. You have your vernier scale and you have your main scale reading in the center. So when an object is kept in between your in between the jaws, when it's closed, then you measure your length. You take your main scale reading and your vernier scale reading and you add it. Okay, the range for a vernier caliper is around 15 centimeters, but this can slightly vary. Certain vernier calipers may be a little less, like 10 or 12 centimeters, and sometimes it can go up to 20 centimeters. The length or the range here depends upon where the instrument is being used. The precision for your vernier caliper is 0.01 centimeter, and so its accuracy is plus minus 0.1 centimeter. Most common example, you're finding the diameter of a test tube. Next, you have your micrometer screw gauge. Micrometer screw gauge looks like this. Okay, if you look at your diagram closely, this is a wire placed in the middle. You have your anvil and your spindle. This is the ratchet which is used for fine tuning, or when it's closed completely, you move this to make sure the object is placed firmly in between. Then you have your main scale and you have your thimble scale or rotating scale. Then you have this datum line, that is the center line, which is your reference line used for finding your measure. So how you measure it is like this. The first thing you do is you take your main scale reading. It's divided into 0.5. So if you look at the 0, you have 5, 6, 7, 8. The down lines give 0.5. So it's 8.5. And your thimble reading, when you look closely, it's in line with this, which is 40. But you multiply 40 with 0.01. So you have 0.04. You add them both, 8.5 and 0.04 will give you 8.9 millimeters. That is your reading for your thickness of your wire. So here the range for a micrometer screw gauge is around 2.5, which is normally less than 2.5. The precision is 0.1 millimeter, and similarly the accuracy is the same. Now while measuring length, you have certain errors. The first one is your parallax error that occurs when the eye is not placed at the correct position, that is at 90 degrees. So if you look from here, the reading is 4.9, which is more than the actual reading. When you look from the other side, it is less. So you have to look at 90 degrees. Same thing for your micrometer screw gauge. At different angles will give you wrong. Similarly, when you look over here, for voltmeters and ammeters, the same issue occurs. So they have a mirror behind, and when you look, you have to make sure that there is no shadow on the mirror. So making sure no parallax error has occurred. The next error occurs normally is your zero error, when the measurement is taken at a point beside zero. So when you look at your micrometer screw gauge, you have two errors. Either when you have a positive zero error, that is when the thimble is below the datum line. So what happens is you take that error, the value, and you would subtract it from your actual readings. When it is the opposite, that is your negative zero error, you add it. Fine. So from your final reading, you minus or add depending upon what error you have, whether it is positive error or negative error. That's it for today. Thank you so much. Hope to see you again later.